Hi friends, in this video we are going to discuss about how we are going to calculate the equivalent resistance, equivalent reactance and equivalent impedance in the equivalent circuit of a transformer. Okay, so here equivalent circuit diagram of a transformer. Okay, equivalent circuit diagram of a transformer. Now we know that in any transformer, so we have primary winding and secondary winding, and we know that in the primary winding we have the value of resistance R1, and in the secondary winding we have the value of resistance R2, and in the primary side we have the value of X1, that is leakage reactance in the primary side, and the value of X2 in the secondary winding, that is leakage reactance in the secondary side. Okay, so before I am going to discussing about the equivalent circuit diagram of a transformer calculations, those are calculation of resistance, reactance and impedance. First I will draw the equivalent circuit diagram of a transformer for the calculation of resistance, inductance and impedance. Okay, so this is the actually basic, this is a basic circuit diagram of a, this is the circuit diagram, equivalent circuit diagram of a transformer, and I am considering only the value of resistance in this particular winding, or sorry, equivalent circuit diagram. Okay, now we know that the supply we are connecting to the winding we are calling as primary winding, and for example R1 is the value of resistance in the primary winding, the value of R2 is the resistance in the secondary winding, and here this is the load, and the load we are connecting to the winding is called as secondary winding, and here this is the transformer. Okay, and here N1, N2. N1 represents the number of turns in the primary side, and N2 is the number of turns in the secondary side. Okay, now actually in this particular topic our question is to find equivalent reactance in the primary side and secondary side. For example, question is find equivalent resistance in primary side. So question is find the equivalent resistance in the primary side. Okay, it means what? We need to find the equivalent resistance for this particular transformer equivalent circuit, that too in the primary side. Okay, so if the question is calculation of equivalent resistance in the primary side, means what we need to do? We need to transfer the value of R2 from secondary side to the primary side. So this process we are calling as referring. Okay, referring, it means refer the value of R2 in the secondary side to the primary side, and whenever we are going to referring or transferring the value of R2 from secondary side to the primary side, we always divide with k square to that particular value. Okay, so here just see here, actually we are calculating the value of equivalent resistance in the primary side. If we are going to find the value of equivalent resistance in the primary side, then what we need to do? We need to transfer, or we need to refer the value of R2 which is present in the secondary side to the primary side, and whenever we are going to referring the value of R2 from secondary side to the primary side, then we always divide with k square. Okay, so this particular new value we are calling as R2 dash. Okay, so here R2 is the, okay, here R2 is the resistance value in the secondary side. If we are referring this R2 towards primary side, then we need to divide with k square to that particular value of R2. Then whenever we are dividing with k square to that particular original value, then we will get new value of resistance, that is R2 dash. Okay, so that is the reason why. So whenever we are going to referring the values of resistance or reactance or impedance from secondary to primary, always we need to divide with K square. Okay, but what is K here actually? K is transformation ratio. K is transformation ratio. Transformation ratio. Here K square means, for example, if K is equal to 10, then we need to take 10 square, because we need to refer or we need to send the value of R2 from secondary side to primary side. Now see here, for example, what I am doing, I am going to considering the value of R1 is equal to, for example, R1 is equal to 10 ohms, and here for example R2 is equal to 5 ohms. Now whenever we are going to referring the value of R2, whenever we are going to referring the value of R2 from secondary to primary, we are dividing with K square. For example, here the transformation ratio is equal to, for example, 2. Then how we are going to find here with the help of this K value? So the value of R2 dash is equal to 5 divided by, so 2 square. 2 square means what? 4. So here the value of R2 dash is equal to, so 5 divided by 4 ohms. Okay, 5 divided by 4 ohms. If I am going to replacing or if I am going to substituting the value of R2 dash after referring from secondary to primary, then the circuit will becomes like this. Okay, now just see. So this is the value of R1. R1 is equal to 10 ohms, and we are applying some voltage, and here whenever we are referring the value of R2 from secondary to primary, it will becomes R2 dash, and here R2 dash is equal to R2 divided by K square, and with the help of the value of 5 and the value of K is equal to 2, actually 2 square means 4. So this is the value of new value of a resistance after referring from secondary to primary. Okay, now whenever we are referred from secondary to primary, then we no need to consider the value of R2 again in the secondary side. Okay, now see here. So this is the load, and here this one is the source. Here R1 and R2 dash both are connected in series. Then equivalent resistance in primary side, equivalent resistance in primary side is given by R01 is equal to R1 plus R2 dash, and we know that R1 plus R2 dash means what? R2 divided by K square, and here R1 is equal to 10 plus R2 means what? R2 means 5 divided by, so K means 2 square, so that we are getting 10 plus 5 divided by 4. So if I am going to simplifying this particular value, so here 5 divided by 4 means, so we will get the value of 1.25. So 10 plus 1.25, that is equal to 11.25 ohms. So this is the value of equivalent resistance we calculated in the primary side. Okay, now for example question is find equivalent resistance, find equivalent resistance in the secondary side. So question is find the equivalent resistance in the secondary side. So I am considering same problem, same equivalent circuit I am considering here. This one, for example, R1 is equal to 10 ohms. I have taken this value in the previous step also, and here this one is the value of R2. So here R2 is equal to actually 5 ohms we taken. Now this is the load we are connecting, and here N1 and N2 are there, and we know that transformation ratio K we considered as, for example, 2. Okay, K is equal to 2. Here question is what? Find the equivalent resistance in the secondary side. It means we need to find the value of equivalent resistance in the secondary side. So if you want to find the equivalent resistance in the secondary side, then what we need to do? We need to refer the value of R1 which is present in the primary side to the secondary side. And whenever we are going to referring or transferring the value of R1 in the primary side to secondary side, then we always multiply with the k square for that particular value of what? Original. So whenever we are going to multiplying R1 with the k square, then it will becomes or it will gives the new value of resistance. So new value, I am giving the name for the new value of resistance is R1 dash. So for example, we know that the value of R1 is equal to 10, R2 is equal to 2 we considered. So 2 square means you will get 4. So here 10 into 4 means we will get 40 ohms. Now whenever we are going to converting or whenever we are going to transferring from primary to secondary, we are getting the value of new resistance R1 dash and we transferring this value to the secondary side. And after transferring, the circuit will or equivalent circuit will becomes like this. So this is the applied voltage, and here this value is R2 is equal to 5 ohms, and we referred the value of R1 from primary to secondary. It will becomes R1 dash because R1 is the new value of resistance. So here R1 dash is equal to R1 into k square, and here we connected the load. This one is a load. Okay, now here R2 and R1 dash both are connected in series. Then the equivalent resistance is given by R02. It means what? R02 is the equivalent resistance in the secondary side. Okay, so R02 is equal to, so R1 dash plus R2. Here R1 dash means what? R1 into k square plus R2 means what? Again R2 is same value, we know that is 5 ohms. Now here R1 means how much? 10. K square means how much? 4 plus the value of R2 is 5. So here 40 plus 5. It means we will get 45 ohms. Okay, so here R02 is equal to 45 ohms. So like this we need to find the value of equivalent resistance when we are going to referring from primary to secondary and secondary to primary. That is the reason why sometimes we are calling as referring. Okay, referring means refer the parameters which are present in the secondary side towards primary side, or refer the parameter which are present in the primary side towards secondary side. If we want to find the equivalent resistance, equivalent leakage reactance or equivalent impedance, we need to follow the same procedure while we are converting from or while we are referring from secondary to primary and primary to secondary. So that is the reason why you need to remember the most important point is if we are referring from primary, okay, if we are referring from primary to secondary side, then if for example resistance R is there, if we are referring from primary to secondary, it will becomes R1 dash, and here R1 dash is equal to R into k square. Okay, if we are referring from primary to secondary, we need to multiply it with k square. For example, if I am going to talking about the reactance, that is leakage reactance, again it will becomes x dash is equal to x into k square. If I am going to referring the value of impedance from primary to secondary, then it will become z dash is equal to z into k square. Okay, so these are the most important steps while we are referring from primary to secondary to calculate the equivalent resistance, reactance and impedance. For example, if I am going to consider, or if I am going to referring from secondary to primary, for example secondary to primary, then if I am going to referring from secondary to primary, it will becomes new value, that is R dash, and here R dash is equal to R divided by k square. And if I am going to referring from secondary to primary, that is impedance, then here z dash is equal to z divided by k square. For example, if it is x, that is reactance, then x dash is equal to x divided by k square. Okay, the most important point is, if you are referring from primary to secondary, we need to multiply with k square for that particular parameter. If we are referring from secondary to primary, we need to divide with k square to that particular value. Okay, this is the procedure we need to follow whenever we are going to calculating the value of equivalent resistance, equivalent reactance, equivalent impedance in the primary side and secondary side. Thank you so much for watching, and please do subscribe my channel for more updates. Thank you.